afternoon, everyone. Today, PTV experts Binny Paul and Adam Groves have a presentation on rapid deployment of ActivitySim with open network data in PTV Visum. Just a couple of items before we get started. Adam, would you mind sharing your screen? Or Binny?
Yeah, I can do that. Just give me a second.
Perfect, thank you. So just a couple items before we get started. Just a reminder, we'll provide a recording of the session sent in a follow-up email. At the end of each session, we'll have a Q&A, and you can enter your questions in the question box at any time throughout the presentation. Our last PTV Talks session is PTV Visum on June 15th. We will send out an email separately to register for that session. Also, if you're interested, please join one of our next web-based training courses. We have Visum, UDAs, and attribute modifications today, June 1st, and Visum roundabouts on June 22nd. You can find more information about these trainings, pricing, and registration at ptvgroup.com under events and trainings. And we have a few poll questions today that will be asked throughout the webinar. They will only take a moment of your time, but we appreciate your participation. And now I'll let Binny take over to start our presentation.
So before we start, Adam, you think it's a good time for a poll question in the beginning, or should we wait?
Yeah, go ahead.
So our first poll question is, would the ability to quickly deploy an activity-based model make you more likely to use ABM? And I'll give a couple seconds for everyone to answer. And I'll close this in 3, 2, 1. Perfect. Thank you for participating in that question.
Cool. So let's get started. And we can come back to other poll questions after we have covered a few topics.
Perfect.
All right. So good morning or good afternoon, everyone, depending on from where you're joining. My name is Binny Paul. I'm a senior modeler with the PTV Group, and I'll be leading today's PTV talk. And the topic for today's talk is rapid deployment of ActivitySim with Open Data Network. And this is our agenda for the talk today. We'll start with a brief introduction and background, and then we'll introduce the rapid ABM deployment framework, and then we'll go through the various components of this framework. And towards the end, we'll have some time for Q&A. So we'll cover some of the questions that you may have. All right, so with that, ABMs, I assume most of the attendees would have some familiarity with ABMs, or at least would have heard of ABMs. And ABMs, they have been around for quite some time. Activity-based models, as they are called, they offer many benefits, and over the years, they have been enjoying a higher rate of approval. And no doubt, that there's a very high consensus among modelers that ABMs offer many benefits in terms of what you can do with them and the type of policy questions that they can be used to answer and things like that. However, they pose a lot of development challenges in terms of they have usually higher costs for development, and that's because of longer development cycles. It may take months to years to stand up an ABM, and then most agencies and MPOs they do not have the technical staff resources to work on these ABMs, and sometimes these ABMs can be complex, and all of these factors together lead to uh, pose challenges that shy away all these agencies away from ABMs. And it's only major cities and bigger MPOs that have an ABMs right now, and smaller MPOs in smaller cities, even if they wanted to test out an ABM, they because of these challenges they're not able to test it out. So over the years, people have come around with workarounds, how to work around this problem of higher cost and technical resources and longer development times and all that. A simple solution is to transfer a working ABM from a similar region and then calibrate that model to your local conditions. And this has worked pretty well over the years, and uh, there has been a high success rate in transferring of models from one region to the other. And most recently, with the rise of ABM platforms like ActivitySim, this process has been simplified because it just standardizes the ABM implementation itself, so it makes it very easy to transfer ABMs from one region to another. But still, even if you transfer the model, there is still the task of developing all the inputs for ActivitySim, calibrating them, and then combining everything together, because ABMs usually have multiple moving parts and you have to combine everything together. So uh, even with this simplification, it still remains a challenge in terms of cost and effort. We are living in a time of automation and AI and all of that, and deploying automation tools and streamlining this workflow can definitely help accelerate ABM development process. And there are a lot of products out there. PTV has a new tool or a new product called PTV MODELZGO, which can automate creation of a lot of the inputs that are required for travel models. And such tools, with use of a lot of Python and machine learning in conjunction with PTV Visum and ActivitySim, it can generate a lot of synergies to expedite this process of ABM development. So this is what we are going to talk about, how all these different products can be used to create a framework for rapid deployment of ABMs. And so before we move on, for those of you who do not know what ActivitySim is, it's an open platform for ABMs. It's being supported by more than 10 big MPOs across US. It has a growing user base across the world, and it also includes PopulationSim as to be used for population synthesis. So that's ActivitySim in a nutshell. And PTV Visum, most of you would know about PTV Visum. It's the world's leading transportation planning software. It has a lot of cool features and algorithms and methods for all your travel demand modeling needs. And most recently, a lot of work has been done for support for activity-based models, and this was done in phases. And we will talk more about what features are available for activity-based models and ActivitySim in particular, and how all these features contribute to this rapid deployment framework. And lastly, PTV is a MODELZGO. It's again a product to quickly create a transport supply model for any area in the world. And it uses a lot of advanced technology and machine learning to automate a large part of model building process. And we can deliver a basic transport model for any city in the world in just 1 week. All right, so let me introduce the rapid ABM deployment framework. So this framework consists of 4 core steps. In the first step, an automated network is developed using PTV's MODELZGO. And then in the next step, PopulationSim is used to generate a synthetic population. And then in the third step, ActivitySim is deployed as the ABM. And then finally, ActivitySim is calibrated to the local conditions, to the region, for the region for which it's being implemented. And all of this is combined or integrated together with PTV Visum. PTV Visum, it provides the necessary connecting pieces for the rapid deployment workflow. So all the components that I talked about, they can be automated, and you can do a lot of things to make the process of implementing those components faster. But it still needs a glue which holds them together and provides all the necessary pieces to talk to each other, and just to streamline the whole workflow. And PTV Visum offers all those features. So there is feature to import synthetic population directly from PopulationSim. There is support for multiple zone systems. As you would know, ABMs, unlike trip-based model, ABMs can have multiple zone systems. You can have TAZs and also have microanalysis zones. And for on the transit side, you can have transit access points for skimming. So PTV Visum supports these multiple zone systems. And not just that, it also supports skimming for all these zone systems. You can have task-to-task skims, MAZ to MAZ skims, or tap-to-tap skims. And you don't really have to, create a new model for each of the zone system and do in any of those gymnastics like that. But everything happens seamless within the same one model system. And then there is support for ABM data structures. There are ABM objects like locations, households, persons, tours, and trips. So this just makes it so easy to import synthetic population or to import back ABM outputs. And then there's a very tailored ActivitySim interface in Visum UI, using which Visum can connect to ActivitySim. PTV also contributed to the ActivitySim project by developing an ActivitySim installer, which just makes it so easy to install ActivitySim. So you can, using this installer, you can install ActivitySim on your machine just like you would install any other software. So all these features, along with other PTV products like PTV MODELZGO and Visum Publisher, it all gels together so well and results in a very streamlined system, which can help in rapid deployment of ActivitySim for your region. So with that, let's go through the different steps that I talked about in this workflow. So the very first step is developing an automated network using PTV MODELZGO. And as I mentioned, PTV MODELZGO, it combines automation with new data sources and reduces time and effort for the creation of a standardized transportation model. Now, this PTV MODELZGO, on the other hand, we have PTV Model Factory, which is just a team of GIS, data science, and modeling experts. So PTV Model to Go would give you a standardized transportation model, but if your project requires certain customization, then you can work with PTV Model Factory, and we can get all those customizations depending on your requirements and the need for the project. But for standing up a basic ABM, just a standardized transportation model should be good enough to start with. But depending on your requirements and project needs, we can always work with you. So what you get with the PTV Model to Go, user supplies a model boundary, and on the right hand side here you can see it's a very rough boundary of the SERPM model for the Miami, Florida region. And once you give us that, what you will get a model, a standardized transportation supply model in return, which would contain a roadway network. It would have details of public transportation network, lines and stops. It also creates zones automatically, and the number of zones is chosen by the user. It can also generate connectors, point of interest, zonal production attractions, and optionally also junction details. So for this workflow, you may not require everything that is stated here, and but this is just for your information to know, what all will be there in your model to go network, and you can use it for different purposes depending on your use case. And another thing that I want to note here is some of these features, PTV Visum already has some of these features, like you can import an open OSM network into PTV Visum. There's also a feature for generating connectors automatically in Visum. But PTV Model to Go takes it a little further, and there's a lot of logic behind generating those connectors and zones. I will talk about that just briefly. So zones, as I said, they are generated automatically. User specifies the number of zones, and the process, it honors various admin boundaries and natural barriers and such. Alternative to this is the user can supply their own zones, and in the ABM development workflow, usually the user would have their own zone systems, which could be coming from their existing trip-based model, or it could be coming from some other sources. But if zones do not exist, then zones can be created. The roadway network model, the source for the data is TomTom here, or OpenStreetMap, depending on where your region is. And then what comes in that network, there is link categorization in terms of like functional road class and such. There is a speed limit, link capacity is derived from link category, number of lanes, and highway capacity manual. And then for the nodes of the road network model, they also include elevation data. And as I said, optionally, there could be junction geometry, which could be used for various other purposes, but this is not very relevant for an ABM development. And on the transportation side, public transport side, the source is public GTFS feed. We can also work with your own GTFS data, and then there's the rail network. And in the end, what you get is stop and line routes, everything automatically matched to road and rail networks. So if you're interested in learning more about Model to Go, we did do a presentation on this, and you can check out our technical resource hub to learn more about it, or you can contact us if you're interested in learning more about Model to Go. But for this workflow, we can simply assume that using PTV Model to Go, you can get a fully routable, very detailed network required for an ABM, and it can include zone system and also public transportation data. So the next step in this workflow is generation of synthetic population. And for this, we use the tool called PopulationSim. And PopulationSim, again, it's an open platform for population synthesis. It's implemented in ActivitySim framework, and it is managed by consortium. There are different various advantages. It has advanced algorithm. You can work with multi levels of geography, and there are faster run times compared to many traditional population synthesizers. It has a nice wiki and user guide and everything that you can refer to for instructions on installation and configuration and such. So normally this is the workflow for generating synthetic population using PopulationSim. You start with data download, and this can be fairly automated with the especially now that we have census API functionality. And then next step is to prepare all the inputs for populations in this. These include the seed sample, marginal controls, and if you are using multiple geographies, then you need a crosswalk between your geographies. And finally, after that, the next step is to run PopulationSim. And if you are generating group quarter population for your region, then you need to run it separately for households and for group quarters. And then finally validation and parameter tuning. PopulationSim provides you with a lot of controls and levers to manage how your synthetic population should look in the end. So those could be tuned, and it affects the validation. So validation and parameter tuning is another task. And then finally post-processing, which includes coding your final synthetic population in the required format for ActivitySim. So if all these steps are done independently, it can the process of generating synthetic population can turn out to be really cumbersome and tedious. There in this framework, what we do is we try to combine all these processes together in a single script, and then expose all the settings in a single YAML file for the user. So you can specify things like how to define your region, from where to download the data, and then define your definitions for crosswalks, how to um, generate marginal controls, details for your processing your seed sample, and then how to do validation, and then if there are any post-processing steps. So you are it's sort of a single stop shop for performing all configuration, and then you can simply run that script, the Python process, which goes through all these sub steps. And this you don't have to configure any of the scripts or anything. All since all the settings are exposed here, it makes it very easy for the user to configure and generate a synthetic population for any region. You just got to specify, you can supply a model boundary, and using that model boundary, appropriate data is downloaded, a crosswalk is created, and all the marginal controls and seed population is generated. The one of the challenges in PopulationSim has been how to validate and how to tune various parameters. So in terms of validation, we mainly look at two metrics. First is how well the controls are matching, and then the uniformity of controls. And there are two PopulationSim parameters that are exposed to user, which usually affect the validation are maximum expansion factor and importance factors for controls. How important each control is. And maximum expansion factor, as the name suggests, it defines how much each seed record can be expanded. So in this framework, what we have created is you can define a range of these factors, and the framework would iterate over those factors, and in the end would compute a validation score for each of these runs. And then in the end, the run with the best validation score is retained. So that this and it would generate a report in the end for you to see how each of the runs performed in terms of validation score. So it's pretty cool, and it helps you try out multiple runs, because if you do each of these runs individually, it's very hard to keep track of what worked and what did not work. And this automates that process and reduces the amount of time that you spend on generating synthetic population. And it doesn't end there. Once you have generated synthetic population using features in Visum, you can import that synthetic population back into Visum. That there's a GUI for that. You can go to File and then PopulationSim and import. You can point it to the PopulationSim setup, and it will import persons and household file into Visum. Alternate method is to use Visum's Python API to do the same thing. And once you have a synthetic population within Visum, you can transform that data, or you can perform different type of graphical analysis. Here on the screen for the Miami region, you can see um, what is being displayed is average household income for each MAC. Okay, so let's move on and go to the next step, which is deploying ActivitySim. And when it comes to ActivitySim deployment, there are two steps. The first step is to configure ActivitySim, and the second step is to configure the integration of ActivitySim with Visum. So setting up ActivitySim, before you start integrating ActivitySim with Visum, the assumption is, or the prerequisite is, an ActivitySim setup should be existing, and you can point Visum to that existing ActivitySim setup. On ActivitySim website, there are a lot of existing examples that you can start with, and then configure it to match to your local conditions. So it may seem like a very big task of transferring an example ActivitySim setup to your region, but there are only a few things that you really need to change to get the ActivitySim to start working for your region. And one thing that we didn't talk about was the land use data. So land use data, at least in this workflow, it is assumed that it is provided by the agency. Usually agencies do have their own land use model, or land use data could be borrowed from the existing trip-based models. But if there is no land use data, Model2Go also has features where it can produce some level of land use data to be used in ABMs. All right, so coming back to configuring ActivitySim for your region, a typical transfer requires changes to following settings in ActivitySim. First is input specification. Synthetic population and land use data could be different, so that needs to be configured, and then usually the aggregate time period definitions could vary across regions, and then destination choice variables, that again depends on how different land use data is, what type of classifications you're using for your land use variables, and then how you're segmenting decision makers, workers, and students. And I think the most or the most complex or the most involved change is tour and trip mode choice definitions. And depending on how different it is, that can be a big task to configure tour and trip mode choice definitions. And depending on the type of structure that you're using for tour and trip mode choice, you'll have to adjust your skimming procedures accordingly. Now, an alternative and for much faster deployment is you can use PTV's ActivitySim example for the Miami, Florida region, which has a lot of standardized um, configuration and more definitions and such. And this would make your life very easy, and it can quicken your ABM deployment. So we'll talk through some of these. Input specifications, generally it's changed in the main configuration settings file for ActivitySim called settings.yaml. And what really needs to be changed is you need to specify all your columns and then rename them if needed. Aggregate time periods, again, there are two files that needs to be changed where these more time period definitions are specified. And destination choice variables needs to be specified in the destination choice size terms configuration file. I'm not going to go through all of these, but this is just to show you that there is uh, only a bunch of files that you need to change when you're transferring ActivitySim from another region to your region. And this part, as of now, this has not been automated because this does require a little bit of judgment on part of the modeler. But we have sort of created a playbook, and you can work through the steps in that playbook to determine what needs to be changed and what doesn't need to be changed. Right, and next is the worker and student segments. So worker segments is something, how you're segmenting workers for workplace location choice models. So in many models, they are segmented by income groups. They could also be segmented by occupation type, which industry they belong to and such. And for students, the segmentation is by their school attendance, preschool, grade school, high school, university, etc. So these are like typically what is what needs to be changed when you're transferring ActivitySim. And as I mentioned earlier, the most involved is updating tour mode choice structure. And this requires some familiarity with the ActivitySim framework because there are a bunch of files that needs to be updated if you plan to um, uh, change the mode choice tour or trip mode choice structure. And this is how a mode choice model is specified in ActivitySim. But again, if all of this this can be overwhelming for a new user. So a simple solution, especially if you're just starting out and if you want to quickly deploy an ABM for your region, uh, a simple choice is to start with PTV's example. And doing that, you get a standardized mode choice structure. And this example was created for the Miami, Florida region using Sandag's two-zone example. It has 3 aggregate time periods, and then worker segments segmented by 6 occupation groups, and students are segmented by as preschool, grade school, and university. And the benefit of using this example would be it comes with all the skimming infrastructure. So the skimming required for this mode choice structure will be included in that example. So that would make your life very easy, and it would cut short the development time by a lot. And once you have an initial model running, you can slowly build up on that and change mode choice structure or anything else that depending on the requirements for your project. All right, so once you have configured the ActivitySim setup, the next step is to integrate ActivitySim with Visum, and for that there are 3 steps, and for each of these steps there is a procedure in Visum. So first is to export ActivitySim inputs. So as I mentioned, Visum provides an integrated data management solution. It's an integrated data model. You can store both supply and demand side of data in Visum. And this procedure exports all the required inputs for ActivitySim, which includes land use data, synthetic population, mass to mass skims, task to task skims in the right format. And just once you run this procedure, it would spread out all these inputs in the folder that you specified for ActivitySim. Next is to point the start ActivitySim procedure to the install ActivitySim executable. And only thing required here is to point it to the ActivitySim executable, which you can easily install using the ActivitySim installer. And finally, the third step is to import back ActivitySim output. So once ActivitySim run has completed, it produces a final household and person file, tours and trips, and also trip tables. And all of that could be imported using this procedure. And finally, once you have all of this, you can add more things to your procedure sequence with ActivitySim. You can add skimming and assignment, and if you have auxiliary model components, you can add that, and you can complete the model loop using Visum's procedure sequence. One thing I want to note here is the PTV's current ActivitySim example, it does not include any auxiliary model components, but for a starting model, what you need is skimming infrastructure, a demand generation ActivitySim loop, and then assignment. And once you have that running, you can easily build up on that and add more components as you like. I think Adam, it'll be a good time for it's a good time for the second poll question, I guess.
Perfect. Do you have projects or clients that would benefit from an ABM but currently use a 4-step model? And a couple more seconds to collect the final responses. And we're going to close the poll. Thank you.
Yep, thank you. So let's keep going here. All right, so the final step in this workflow is calibrating ActivitySim. And traditionally, ABM calibration was a very long process because to calibrate a single model, after each adjustment, you had to do a full model run. And that used to consume a lot of time. Even with, running a 20% sample for calibration, it used to take very long because you have to, you know, do a full model run. But with ActivitySim, the way it has been designed, it's possible to um, resume a run from a specific point in the model. So you can see here the sequence of models in ActivitySim, and that there is a runtime argument called resume after step, and this could be used to resume a previously run model from any of these, in any point in this model sequence. So this feature can be used to quicken the calibration process, and you can do multiple runs of the same model to adjust calibration coefficients. However, as you know, in ABMs, all the models are sort of interconnected. The upstream models, the outcome of the upstream models affect the outcomes of the downstream models, and then also the downstream models, they feed back into the upstream models. So it's necessary to do a full model run in between while you're calibrating individual models. So you can come up with a sort of a calibration plan, and in this calibration plan, you can specify the number of global iterations that you want to do, and within each global iterations, how many iterations of individual models that you want to calibrate. And for this, the rapid deployment workflow, there are mainly three models that we look to calibrate because we feel these are the most important ones, and also these are the ones that usually vary, from region to region. And these include auto ownership, destination choice, and then tour and trip mode choice. So this procedure, you know, takes an existing ActivitySim setup and target distributions for these models, and then it would run ActivitySim depending on how many iterations the user specified, so many global iterations, and then within each global iteration, individual iterations for all these models. So that's calibration in a nutshell. There is not a lot of science to calibration. It's just comparing model outputs to target distributions, and depending on how different they are, apply adjustments and copy over those adjustments to ActivitySim configuration file, and just got to do this in a iterative fashion. While this process can be automated, one thing to note here is the user should look at the calibration adjustments in the end, because uh, sometimes you can the calibration coefficients can hide existing problems in your model. So that's just a disclaimer, but um, the process can be automated, and to save you a lot of time. So once you have set up everything, you have an initial model running, you have sort of calibrated it to the local condition, and now since if you the real benefit of Visum acting as a shared platform for different components comes when you start analyzing ABM outputs. And there are a lot of features that are available in Visum that you can use for ABM output analysis. You can import all the ABM output into Visum, and all the data tables, they are interconnected. So let's say if you click on a tour for a person, it would highlight the trips that are associated with their tours, and then the activity executions that are associated with those trips. Same goes for household and persons. If you click on a household, then it would light up all the persons that are associated with that household and so on. So this is very useful when you want to analyze your ABM output. In this example, so this person has it's a female, 71 years old, and is a worker, and has only one work tour, and the tour has 3 trips, and they start at 8 a.m. in the morning, and then come back around 5 p.m. in the evening, and then on the way back they stop at some place for a eat out activity. And for this tour, drive alone was mode. And this is real example from the our PTV's SERPM example. And at the same time, you can also visualize that tour in your network. So the same tour, you can see this is where this person's home location is, and this is their work location. And while coming back, they stop at a location here for a short eat out activity, and then come back home. And there's a lot more that you can do with Visum and ABMs. There are features like you can look at activity profile for a number of zones, and you can perform select link analysis. These are called as flow bundles in Visum. And Visum, when you do assignment, it assigns path probabilities for each trip. So using that, you can um, create a demographic distribution for select link flow. So you can answer questions like what is the income of users of the select link, and where do they live, where the trips are originating from and where they are going. So this can help you with analyzing your ABM outputs in a very unique way. And same is possible on the transit side, where you can do a select stop analysis and then answer questions like what is the age profile of transit users on this link or on this stop, and so on. And finally, you can also connect your ABM results online with PTV's Visum publisher to create custom dashboards that you can share with decision makers, or collaborate with team members and so on. And it has cool features like simulation of trips on your network, and you can create a small video of it, and and there's a lot of other things that you can add to your dashboard. So I think with that, that brings us to the end, and also the time for the third poll question.
Would you like additional information on this process, or would you like to speak about using this in your work? And a few more seconds to collect the final answers. And I'm going to close the poll. Those are all the poll questions. Thank you for participating today.
Thank you. And Adam, I think I don't know if there are any questions, but maybe we can take a few.
Yeah, definitely. There's a few questions, and if anyone else has any additional questions, please feel free to go ahead and enter them now. We'll try to get to as many as possible. I did want to point out real quick as well that for any of you who are attending next week's TRB Innovations Conference in Indianapolis, Binny's going to be doing a similar presentation there, and myself and him will be there as well if you have any additional questions. All right, first question, Binny, is the PopulationSim rapid deployment something that PTV is sharing openly, or is that a licensed tool?
Well, I think it will be part of this entire framework, and we can definitely talk with you and discuss a plan how we can go about it. So we can talk about this offline, and yeah, please contact us.
Yeah, definitely, and we'll get in touch with that person for sure. There's a question about, you mentioned MODELZGO having land use data. Can you talk a little bit about what land use data is available in MODELZGO?
Yeah, sure. So MODELZGO has, let me go back to that slide. I don't know if I have. Yeah, so it does have things like point of interest from here and other sources, and using this, zonal productions and attractions can be estimated, and just from this point of interest data, the land use data, like things like how many parks are there and how many shops and things like that, which can be converted to land use data, which can be used as attractions on the ABM side, and as productions and attractions for a trip-based model. I don't know, Adam, if you want to add anything to that.
Yeah, I think you covered it pretty well. It's using that point of interest data and using that to make some assumptions. There may be, still opportunity for you to review that depending on the process and make sure that all that stuff is well aligned. But if you do have interest in some of that, we can generate some of these like sample geographies and let you take a look at them if you have a project you're looking at. That's something we can do prior to actually purchasing a MODELZGO. We can generate that for you, walk you through it, and kind of see what's there. And can you talk maybe where you'd be able to get those configuration files that you mentioned, or what would be a good source of like starting point for those configuration files?
I'm assuming this is for ActivitySim, and you can start with an there are a lot of examples available on ActivitySim's GitHub repo. You can go to just activitysim.github.io, and you can access these examples. And within each example, there'll be a configs folder, and within those configs folder, you can find all the different configuration files that I talked about. And the PTV example, ActivitySim example, also has a similar set structure. We have a configs folder, data folder, outputs folder, and inside those configs folder would be what is our configuration for our example.
Yeah, and just on the ActivitySim side, I would point out if you're in Visum version 2023, there is a full ActivitySim, or I guess I shouldn't say full, it's a rather small example in the example file. So if you go to help examples, open examples directory under the demand ActivitySim folder, there is an example there, so you can see the setup for that example, right within Visum.
Yeah, thanks for noting that, Adam. Yeah.
And I think with that, we're kind of coming up on time here, so we can go ahead and close out today's presentation. Thank you for everybody who joined, and thank you very much, Binny, for the presentation. Just as a quick reminder, you will get a copy of the presentation, a link to the recording to this, but also, please feel free to reach out with any questions you may have to either myself or Binny. Tiffany, do you want to close us out?
Last but not least, if you have any questions, feel free to email us also at marketing.us@ptvgroup.com. And I hope everyone has a great day.